Good evening to everyone. My name is Dr. Vasanthi. I am Assistant Professor in Department of Mathematics from CPA College, Bodinayakanur. Today we have to discuss about the partial differential equations. It is under its applications. The main method is we have to see the Lagrange's multipliers. First we have to see the method of Lagrange's multipliers. The main part of the Lagrange's method of multipliers is involving the local minimum and the maximum of a function with the two variables subject to the conditions or constraints on the variables involved. Suppose the constraints g of x comma y equal to 0, the function z equal to f of x comma y has a local maximum or a local minimum at the point x0 comma y0 from the function f of x comma y comma lambda equal to f of x comma y plus lambda g into x comma y. Then lambda is a solution of the system of equations dou f by dou x equal to dou f by dou x plus lambda into dou g by dou x equal to 0. This is the equation of us. Next we have to find dou f by dou y is the same way. Next we have to see the differentiate with respect to lambda. It's equal to g of x comma y equal to 0. Provided all the partial derivatives exist. First step, when the function is maximized or minimized, then the constraint of the form z equal to f of x comma y subject to the constraint g of x comma y equal to 0. This step 2, constraint the function f capital F of x comma y comma lambda equal to, it can be written as f of x comma y plus lambda of g of x comma y. And the step 3, we have to find differentiate with respect to x and differentiate with respect to the equation of y, and the differentiate with respect to lambda is equal to g of x comma y equal to 0. And finally solve the system of equation for x comma y and lambda. Test the solution x0 comma y0 comma lambda to determine maximum or minimum point. Suppose we have to find the d star equal to, that is called a differentiate function of the Lagrange's multipliers equal to f of xx, it can be written as dou squared x by dou squared y by dou x squared into dou squared u by dou y squared minus dou squared u divided by dou x into dou y. Therefore, suppose d squared divided by dx squared greater than 0, that implies differentiating the differentiating the x is less than 0, maximum point. Suppose x greater than 0, that implies d squared x divided by dx squared is greater than 0, that is called a minimum point. Suppose the d power n less than or equal to 0, that implies test is inconclusive. The step 6, evaluate z equal to f of x comma y at each solution x0 comma y0 lambda. Find the last step. Now see, we have to see the examples of the maximum or minimum of the f of x comma y equal to 5x squared plus 6y squared minus y of the constraint x plus 2y equal to 0. First we have to written as the equations f of x comma y lambda equal to 5x squared plus 6y squared minus xy plus lambda into x plus 2y minus 24. And next we have to find dou f by dou x and dou f by dou y and then dou f divided by dou z. We have to find the values of f1, f2 or f3. Then the critical point 10x minus y plus lambda equal to 0 and 12y minus x plus 2y equal to 0 and x plus 2y minus 24 equal to 0. Then the solution of the equation is x equal to 0, y equal to 9, lambda equal to minus 51. Therefore, we have to find next, we have to find d squared divided by dx squared. What about? Then d squared divided by dx squared greater than 0. Therefore, 10 greater than 0. Then the point is f of x comma y is a local minimum at 6 comma 9. Therefore, f of x comma y equal to 720. Next we have to see the examples. A manufactured products two types of engine, x units of type 1 and y units of type 2. The point, the joint profit function is given by p of x comma y equal to x squared plus 3xy minus 6y. To a maximum profit, how many engines of each type should be produced if there must be a total of 42 engines produced? Maximize of z equal to p of x comma y equal to x squared plus 3xy minus xy subject to the constant x plus y minus 2y. Then the equation can be written as f of x comma y comma lambda. So now we have to find dou f by dou x and dou f by dou y. Now put the point 2 and put the point on y and f equal to 0, f of y into dou f divided by dou y, therefore f of xy equal to 3. So therefore the solution of the system is x equal to 33, y equal to 9 and lambda equal to 93. Therefore t squared divided by dx squared or d to the power of n equal greater than 0. Therefore the test is inconclusive. Next we have to find the minimum of the point of the several examples. Thank you.